Hello, this next section, 10.8, is on the cross-section of solids. So for this, I can identify shapes of two-dimensional cross-sections of three-dimensional objects. And we want to identify three-dimensional objects generated by rotating two-dimensional shapes. So we've kind of talked about this before, but a cross-section is, imagine a plane slicing through a solid. And the intersection of the plane of the solid is the cross-section. So the diagram below shows that an intersection of a plane and a triangular pyramid is a triangle. So the cross-section is this purple highlighted part inside of our shape. And that is just by, if you imagine cutting off the top of your pyramid. And the angle of the plane is going to affect what the shape looks like. And we're going to look at that in our next example. So if we look, my notes got a little bit messed up here. Let's try deleting. Perfect. So if we look here, we're going to describe the shape formed by the intersection of the plane and the cube. So if we look at the first one, this is a cube, so we know the bases are squares. And if we look at this, the cross-section is just flat, just like one of the bases. So the cross-section shape is going to be a square. And then if we look at example B, this one is going diagonally, cutting the cube in half, and that's going to form a rectangle. And then if we look over on the right, this time it's cutting it diagonally, but only part of the corner is coming off. And if you look at that shape, and if we were to draw it off on the side, so we can see it a little bit clearer, that's going to be a trapezoid. And the reason it's a trapezoid is because two sides are parallel, but they don't have the same length of base, and these lines are slanted. So that's going to give us our trapezoid. So if you want to try the next three on your own, you can go ahead and do that. So for this one, we cut it off, and it's going to be a triangle. And if we cut off the top of a cone, we're going to have a circle. And this one, we got to count the number of sides. We have 1, 2, 3, 4, 5, 6. So we're going to have a hexagon. So identifying these 2D shapes when a cross-section cuts into a 3D shape is our goal for today. And like you can tell, it's pretty easy when you are looking at it, and they have highlighted the cross-section for us. So our next part is if we're rotating a cross-section. So for the example, to start with, we have a rectangle. And if we were to take that rectangle and rotate it all the way around this line, it would form a cylinder. So our next goal for today is to identify shapes that would be formed by rotating something, a 2D shape, around a line. So let's look at example 2. Identify the shape that would be formed by rotating the shape around the line. So this time we're going to take a circle and we're going to rotate it. And if we were to take a circle and rotate it all the way around and it would be filled in, that would look like a sphere. Now if you want to go ahead and guess the next one, you can do that. For example B, when a triangle is rotated all the way around a line. Okay, if you have your guess, when you do that, we're going to end up with a cone. And you don't have to draw the lines in that I did, but I did it because it helps me visualize what's going on. So we're taking this one point, we're rotating it around the line, and then as you can see, we get that cone shape. And for the sphere, when we take that circle and rotate it all the way around, we get a sphere. So that is 10.8. If you have any questions on it, let me know, and we'll